looking at square roots. And so we have, also known as SR, is what we can refer to them as. And we are first going to start off with what is the definition and what exactly is a square root. So a square root originates from a perfect square. Okay, so a perfect square is a number that results from multiplying an integer by itself or to itself. So a good example of perfect squares are actually going to be these numbers here. So 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because, well, 2 times 2 is 4. 9 is a perfect square, 3 times 3. And so etc., etc., etc. So all of these numbers on the right are called perfect squares. If I was to actually draw a square and it was a 7 by 7 square, it would have 49 little pieces inside of it, and thus the origin of its name. So feel free to pause this video and copy down any of this information. So given perfect squares, then you still come back to, okay, so what is a square root? Well, a square root becomes this. The inverse operation of squaring is finding the square root. So given it is positive. So what that means is that we had all of our perfect squares, 1, 4, 9, 16, 25, 36, 49, etc., etc., etc. All these numbers underneath this square root or radical sign are perfect squares. So when we square root them, we come back to the number that originally was squared, or the length of one side of the square. So if we had a 7 by 7 square, the square root says what was the number that was being squared, aka the square root of 49 is 7, because 7 times 7 creates 49, the perfect square, 49. So again, make sure you pause the video and copy these down. So some other basic information about square roots is that a square root actually can be negative, because -3 inside the parentheses squared means -3 times -3, which gives me +9. So if you see a sign that's like this in front of the radical sign, aka the square root sign, then it wants to know what numbers, either positive or negative, could be multiplied to themselves and get 9. So thus my answer can be +3, because 3 times 3 is 9, or could be -3, because -3 times -3 gives you a +3. So you can also write it as plus or minus 3. So another bit of information regarding square roots is that you can actually see them in the numerator of a number and or in the denominator of a number. So they can actually be written as fractions. And it's okay, because you can still rewrite them as need be. So the radical of 16/25 could also be rewritten with the square root sign in the top and the square root sign in the bottom. Or you could just have a situation where the radical sign is just in the bottom. Or just in the numerator. And one thing to note is that the square root of 16 is 4. And the square root of 25, well, 5 times 5 is 5. So this number here actually is this big complex number, just what's called simplified. So we'll get more into that a little later. But it's kind of good to know that you can break them up into a radical in the top or in the bottom of a fraction. And then our last bit of information is another way that you can actually see your radicals is in an equation and use it that way. And again, remember to pause the video and copy down these notes as needed. So you can actually write it in this situation as a simple equation. So if we have 3x squared equals 48, we just kind of pretend like it's 3x and divide both sides by 3. So 3 divided by 3 is 1. 48 divided by 3 is 16. But then we have to square root both sides. So we take the square root of x squared, which is going to give us x, and the square root of 16, which we already said was 4. And so just to recap, the reason why x squared, the square root of that is x, is because, well, x times x is x squared, just like 4 times 4 is 16. The rule still applies even if it's a variable. All right, I hope this helped.